As I alluded to earlier, we have this idea of coterminal angles. That's where we might have the same angle, but we got there from a different rotation or multiple rotations. And if we think about it, there really could be an infinite amount of coterminal angles. All right, so what do I mean by that? Well, a coterminal angle in degrees is any angle and then adding a full another rotation to it or subtracting a rotation to it. And likewise in radians, it's add if we add another full revolution or take away a full revolution from it, we would get a coterminal angle. And the definition is theta plus 360 degrees times k, which is the times of revolutions. It's a whole integer. And likewise in radians, times a whole revolution. So let me give you a couple of examples with this to help kind of make it make sense. So let's say that I have 420 degree. I have an angle as a 420 degrees. And let's go ahead and put it in different colors so we get a sense of what's going on here. That angle is formed by going one complete rotation, revolution around, and plus another, what, 60 degrees beyond that to produce this angle. So that's 420 degrees. Well, I want to find a coterminal angle with 420 degrees. I want to find a positive one in this particular case that's less than 360. So what I'm going to do then is I'm going to subtract 360 degrees from this, subtract one full revolution, and that's going to produce a coterminal angle of 60 degrees. And that 60 degrees is just listed right there. So that's a coterminal angle. 420 degrees and 60 degrees are coterminal angles. They are angles that have the same positioning, but we got there from a different rotation. In this particular case, we added a whole nother rotation around the circle to do that. Let's look at another example. And this example is a minus 120 degrees. I would like to find a coterminal angle with that. So its first angle, negative 120 degrees, and it's a negative decision, is roughly in that direction. And we got there, and I'll leave in green, we got there from going that direction. So that's negative 120 degrees. Well, what's its positive coterminal angle that's less than one revolution, less than 360 degrees? So in this particular case, I'll add 360 degrees to it, and that's going to produce 240 degrees. And that mark is in the positive direction, so we'll go this direction down to there. And again, we see we get to the same ray, but the positive route was 240 degrees. The negative route was a negative 120 degrees, and both of those are coterminal angles because their landing points are at the same position. All right, let's look at a couple more examples in radian. When we have our measurement in radian, we add or subtract 2 pi radians, a number of them, determining on what our end result will be. So this particular example, I want to find a coterminal angle with 17.6 pi that's less than 2 pi. So what we need to determine, though, is from this, do we add 2 pi or do we subtract 2 pi? One way to observe that maybe is to write that as a mixed number. This is 2 and 5/6 pi. So I can see then that I should subtract 2 pi from this. So 17.6, take away 2 pi, but I want to have in terms of 6, would make that 12/6 pi. So 17.6, take away 2 pi, this produces 5/6 pi. So I can see I have a coterminal angle then with my first one. 17.6 is a full rotation plus some. And with that, I have another one that's 5/6 of a revolution around, or a rotation around. 5/6 pi. And my original one was 17.6 pi. And I can see, let me clean that up a little bit. So I can see that those two are coterminal angles. When you're looking at it from the radian point of view, the first thing you need to do is determine, do you need to add 2 pi or take away 2 pi in certain circumstances. In this one, I wanted to find a coterminal angle that was positive and less than 2 pi. How do I get there from here? I realized I had to take away 2 pi because I was heavy on it. I need to make it a little bit lighter. And then let's look at negative pi 12ths. Well, negative pi 12ths, I've illustrated here. I want to find its positive coterminal angle that's less than 2 pi. So with my initial one, do I add 2 pi or do I take away 2 pi? And how many of them do I take away? Well, in this one, I only need to take away, or I need to add 1 2 pi to it. So 1 revolution is what I'm going to add to that to get my positive coterminal angle that's less than 2 pi. To add these, I could have common denominators, of course, so negative pi 12ths plus 24 12ths pi. Add those together, I'm left with 23 12ths pi. And that's a coterminal angle. So 23 12ths pi is coterminal with negative pi 12ths. Those both end at the same place. We just got there from a different direction. And with this one, negative pi 12ths, it was a little light, so I need to make it a little heavier by adding 1 more revolution to it to satisfy our conditions that we were asked to satisfy. So let's find some coterminal angles. Now our conditions that we have here is I want to find a positive angle that's less than 2 pi in radian world or less than 360 degrees in degree world. So I begin with an example that's 750 degrees. So the question to you, what's its coterminal angle that satisfies this condition? How we think about then is it looks like we have to subtract a revolution from that. We're going to have to subtract at least 1 360 degrees. In fact, in this one, we're going to have to subtract 2 360 degrees from that one. Subtract 2 from them. 750 minus 2 times 360 is 720. And I'm left with 30, and it was also in degrees. So 750 degrees is coterminal with 30 degrees. Now, how did I know that we had to take 2 revolutions off so quickly? Well, let's look at an example or counterexample. If I start with 150 and I take away just 1 revolution, what do I have left? 750 take away 360 is what, folks? 390? So if I took away 1 revolution, I'm only down to 390 degrees. And that doesn't satisfy my initial requirements, which meant that it had to be less than 1 full revolution, less than 360. So I have to subtract another revolution from that, subtract another 360, and I get to my 30 degrees. So that's helpful for you to understand how many revolutions you need to add or subtract, because your end result has to be within 1 revolution of that circle for our requirements in this particular or in these particular examples. So what do we think we need to do on this one? We have an angle of 22/3 pi. I need to reduce it, or not reduce it, but find its coterminal angle that's positive and less than, in this case, 2 pi world. So how many multiples of 2 pi do I need to subtract from this? It's hard to tell as a improper fraction. So let's rewrite it as an improper or a mixed number, which is 7 and 1/3. So I can see then that I have 7 involved, so I need to subtract 3 multiples of 2 pi away from that. I need to subtract 6 pi. So let's go back then and go to our original problem, which is 22/3. I'm going to subtract 6 pi from that. And that should be the right amount of pi's or right amount of multiples of pi to eliminate, so I get a reduction that's less than 2 pi. So let's work that out and see if that's true. 22 pi over 3. In order for that to work, it has to be over 3. So what is that, 18/3? And I'm left with 4/3 pi, which is indeed less than 2 pi. So 22 pi thirds is coterminal with 4/3 pi. I found the one coterminal angle that meets these requirements. negative 17.6 pi. How many pi's or how many full sets or multiples of 2 pi do I need to add or subtract from this? Well, I know it's negative, so it looks like I'm going to add a multiple of 2 pi, but how many? Well, for some, it's easier to write it as a mixed number to determine that. So negative 17.6 is the same thing as negative 2 and what is that, 5/6? So that 2 is an indicator to me that I need at least to have 2. So if I remove that multiple of 2, I'm still at a negative. So I need to add to this one. I need to add 2 sets of 2 pi to this particular problem in order for it to become just enough to get to the positive side of things, but not too heavy so it's not over 2 pi. So in order to do that, let's look at negative 17.6 because I like adding better in proper fraction form. So negative 17 pi 6 plus 4 pi in common denominator is what, guys? 6. That's a 4. 8, 16. 16. No, I did something wrong, didn't I? 4 pi over 6. What am I not seeing? Oh, it's over 12. Sorry. 12, 24. Do you guys sometimes just stare at a problem and you know what's going on in your head, but it's just not making sense with what you're seeing? Yeah, that just happened to me. All right. Yeah, 24/6 is the same thing as 4, so that was the correct equivalent expression. So let's add those together. That becomes 7/6 pi. So 7/6 pi is coterminal with negative 17/6 pi, but that's the coterminal angle that's both positive and less than 1 full revolution, less than 2 pi. All right, our last example here is a great example to end on because it does add a little bit of a tricky idea to it, but one that if we understand the process and understand some of the things we've learned along the way, we can probably make sense of this. I have a negative 10.3 angle. Well, I don't see degrees and I don't see pi. Well, because we don't see degrees, we assume that this is a measure in radians. Even without a pi, it is still a radian measurement. But what is that measure? What exactly does that look like? How do we know where it fits within the circle? So my best suggestion to you is let's figure out what its degree representation should be. Remember how much a radian was? Radian was approximately 57 degrees. So I have 10.3 radians where each radian was 57 degrees. So what that total amount is then, use a black box, clear that because I got it on the wrong screen. Clear. There it is. Negative 10.3. Nope, I don't want the answer. Start over. 10 point. Boy, numbers everywhere. 10.3 times 57. Did you guys already get it before I did? Equals negative 587.1 degrees. Okay, understand again, this is in radians, but I'm using the degree idea to help me understand how many revolutions I need to deal with. So 587 is where I'm at. I really need to subtract add 2 revolutions to that to get me into the positive realm. 1 revolution won't take it. That's just 360 degrees. So I need to add 2 revolutions to that. However, since I'm in radian world, here's where it gets tricky. So give it some thought. Really think through what's happening. Don't just let this pass by you. Remember, this result is in radians. I use degrees just to figure out how many revolutions I need to go. I found out I need to go 2 revolutions. And I'm going to use those 2 revolutions by putting in 2 multiples in radian world. So I'm going to go around 2 revolutions in radian world. How do I solve this then? 10.3 plus 4 pi. And then if I want to get an approximation from there, let's add those together. So 4 times pi plus a negative 10.3. And that produces roughly a 2.27. So negative 10.3 angle is coterminal with a 2.27 angle. Again, kind of a weird problem because it was started off in radian world. I had to use some tools that are best used in degree world to find out how many revolutions I need to go. I take that piece of information only, pop it back into my original problem, which is in radian world, and add 2 revolutions of radian worlds to that. And that will help me find the coterminal angle. So negative 10.3 is coterminal of 2.27. It's positive and less than 1 full revolution. Now, I get it. You're going to have to do this one again, rewatch this video and practice it a couple times because it's not difficult, but it just feels odd. I get it.